The last type of problem we're going to look at is mixing a strong acid with a strong base, having a neutralization reaction occurring, and determining the pH afterwards. These are simply limiting reactant problems. You have to figure out how many moles of acid and how many moles of base are reacting, and then there's going to be excess of one or the other, excess acid or excess base. And then you determine the pH from there using the excess amount that is left over. For example, if we take 50 milliliters of 0.1 molar HCl and 40 milliliters of 0.1 molar NaOH, what is the resulting pH? Here are the steps to solving these problems. First of all, find out the moles of acid and the moles of base. To find the moles of acid, take the information about the acid and get moles out of it. You're given a volume and you're given a concentration of moles per liter. If you take the volume times the concentration, you will get the moles. You can do the same for the information for a base. So we're going to start with the volume. 50 milliliters is 0.0500 liters of HCl, and we have a 0.1 molar solution, which is 0.100 moles per liter. My liters will cancel. I end up having 0.00500 moles of H+. I'm going to do the same calculation with the base information. I have 40 milliliters of base, which is 0.0400 liters. It is a concentration of 0.1 moles per liter. My liters cancel, and I end up getting 0.00400 moles of OH minus. So I know that 1 mole of OH minus will react with 1 mole of H plus to make water. So I can see here that I have less OH minus than I do H plus. My H plus is going to be in excess. And to find out how much excess H plus there is, I simply have to subtract these two values. So I'm going to take 0.005 moles of H plus and subtract 0.004 moles of OH minus. That will leave me with 0.001 moles of H plus left over. So my solution after I mix these together is still going to be acidic because I have leftover acid. To calculate the molarity, I simply have to determine the new concentration and then take the negative log of the H plus concentration. So since I mixed 50 milliliters and 40 milliliters, my new volume is 90 milliliters. So I can take the moles of H plus that is left over, 0.00100, and divide by 0.0900 liters. That's 50 milliliters plus 40 milliliters. And then I get my new concentration of 0.0111 molar H plus. So then to calculate the pH, I simply take the negative log of that concentration and I get 1.95 for my pH. Let's try another one of these because they can be a little tricky. What about the pH of a solution by mixing 60 milliliters of 0.1 molar sulfuric acid and 130 milliliters of 0.1 molar NaOH? So follow the procedure and you'll be fine. Here's your acid data and your base data. You need to use that data to figure out how many moles of acid and how many moles of base you have. There is a slight trick to this problem when looking at H2SO4. You're going to take 60 milliliters, you're going to multiply by 0.1 moles per liter. But here's the deal. You have 2 hydrogens in H2SO4. So when we get this answer, we want to multiply it by 2. So if you don't do that, you're going to get the wrong answer. You have to look carefully at the acid that's given it to you. If it's H2SO4, you got to remember to multiply the moles of H plus by 2. So this helps us determine our moles of H plus being 0.0120 moles. Now we need to do the moles of base. So we start with 0.130 liters of NaOH. We have a 0.1 molar solution of this, so we got to multiply by 0.1. No tricks here. There's only one OH minus, so we get 0.0130 moles of OH minus. So by looking at this and knowing it's a 1-to-1 ratio, we can see we're going to have leftover OH minus. I have more moles of OH minus than I do moles of H plus. So when I subtract these two, I'm going to have excess OH minus. I'm going to have 0.0010 moles of OH minus that did not react. So now I need to determine the concentration of OH minus after I've mixed these two solutions together. So I need to take those moles of OH minus and I have to divide by the total volume of the solution. So 60 milliliters plus 130 milliliters is 190 milliliters, or 0.190 liters. That gives me an OH minus concentration of 5.26 times 10 to the negative third. So now I just have to work to get to the pH. You could do this a couple different ways. I'm simply going to take the negative log of the OH minus concentration to find the pOH, and that gives me 2.28. So to get the pH, I simply have to take 14 minus the pOH, 2.28, and I get a pH of 11.72. That's how you do a couple problems involving mixing an acid and base together, which is essentially a limiting reactant problem.